All right, let's jump right in. Welcome to this explainer. Today we're going on a deep dive into the really high-stakes adversarial system design used by massive tech giants. We're talking places like Gmail, Meta, LinkedIn, and X. We are going to unpack the incredibly sophisticated, totally behind-the-scenes architecture these platforms rely on to fight spam, abuse, and automated bots. If you've ever found yourself wondering exactly how these platforms keep the floodgates of fake accounts closed without, locking you out in the process, you are definitely in the right place. Let's get started.
To really understand this architecture, we first have to grasp the sheer scale of the threat. We aren't just talking about a few thousand spam emails sitting in a junk folder here. No, these systems are actively evaluating billions of events every single day. That's logins, account signups, private messages, and honestly, every little click or engagement. The engineering challenge is absolutely massive.
So, let's start with Section 1, the billion bot threat. It's a problem of massive scale.
To handle that kind of massive scale, we really have to look at the entire life cycle of a malicious account. From the exact second a fake account tries to sign up, to their attempts to log in, or artificially inflate engagement metrics. But what makes this uniquely difficult is this concept called adversarial adaptation. This isn't just a static engineering problem. It is a relentless cat and mouse game. The very moment engineers build a taller wall, these highly motivated, really well-funded attackers just figure out a way to dig under it. The attackers continuously evolve their tactics to evade detection, which means the defense system has to be incredibly dynamic just to survive.
The overarching objective of this entire defense system is a delicate balancing act. The goal is to detect and stop spam and fake accounts in real time, but with an absolutely critical caveat. You must protect legitimate users. You have to catch the bad guys instantly without catching innocent, real people in the crossfire. Which brings us to Section 2. Behavior over content. This is how engineers are outsmarting the adversaries.
Historically, spam filters looked strictly at content, what a user actually said. But with AI today, attackers can effortlessly randomize text and fake perfectly natural language. So the real aha moment for defenders was shifting to behavior, analyzing how a user acts. Things like superhuman typing speeds or sharing a single IP address with 1,000 other accounts. That is a remarkably robust signal.
And this is exactly why the whole industry shifted. The strongest, most evasion-resistant signals out there are behavioral and graph-based. Think about it. An attacker can tweak a spam message for basically nothing, but forcing them to rotate thousands of clean IP addresses or perfectly mimic human browsing speed, that literally bankrupts their operation.
All right, Section 3, the real-time defense, the frontline security.
Think of these front lines as the security guards stationed right at the main gates of the platform, and they operate under intense time pressure. When you click post or log in, the system has less than 100 milliseconds to fetch your reputation data, analyze your behavior sequence, and score the event. That is literally faster than the blink of an eye. If it takes any longer than that, the platform feels laggy to the user, and that's just unacceptable.
When we look at the complete high-level architecture, every single event hits a risk gateway first. And from there, the whole pipeline splits into two distinct paths. You have a lightning-fast, real-time inline path right across the top, and a slower, much deeper offline analysis path below.
In that crucial, tiny 100-millisecond real-time window, the risk gateway instantly gathers streaming behavioral features and reputation data. It basically hands all that rich context over to the rules and ML score, where complex models, like gradient-boosted trees, make a split-second decision. Is this benign or is it a bot?
Moving on to Section 4, catching coordinated networks, detecting the unseen. Because, real-time scoring has a pretty massive blind spot. It catches the super obvious cases fast, but it completely misses the big picture. This is where the slow, methodical detectives come in behind the scenes. If you look at one account acting slightly weird, well, it might just be a strange human. But 10,000 accounts acting weird in the exact same way? Yeah, that's a botnet.
So to uncover those hidden networks, the system runs what are called offline network sweeps. These are heavy, really complex graph clustering jobs that run in the background. They're looking for deep connections, thousands of accounts sharing a handful of devices, overlapping phone numbers, or even executing synchronized bursts of action. These sweeps are what finally catch the coordinated, inauthentic networks that successfully tiptoed right past the real-time security guards.
To actually win this two-front war, combining both approaches is an absolute architectural necessity. Per-account classification just misses coordinated campaigns, so you absolutely must pair cheap, rapid inline action with heavy, periodic, network-level sweeps to make sure you're covering every single blind spot. Now, on to Section 5, Protecting Real Users, the concept of graduated friction. You see, the system doesn't just swing a giant ban hammer the second it gets a little suspicious. Instead, it deliberately escalates friction. Step 1 might just be a simple capture challenge. If you fail that, Step 2 is a rate limit on how fast you can post. Step 3 could be a shadow limit, where your posts just aren't seen as widely. And only at Step 4, when there is absolute certainty, does it actually block or ban the account. The system vastly prefers these reversible, low-friction actions when its AI models are operating at a lower confidence level. Challenges and shadow limits ensure that if the system makes a mistake, a real user can simply solve a puzzle and move on with their day. Hard bans, those are reserved strictly for high-confidence, coordinated networks.
Because there is this massive, constant tension between strict security and platform growth. Aggressively blocking every slightly suspicious sign-up would completely eradicate bots, sure, but it would also add so much friction that legitimate new users would just give up and leave. The system has to rely really heavily on post-sign-up behavioral detection to avoid overblocking actual human growth.
And because of that tension, the ultimate success of this whole AI architecture isn't just measured by the millions of bots it catches. It's heavily measured by these critical guardrail metrics: the false ban rate, the appeal reversal rate, and ensuring that shared infrastructures, like a university campus or a corporate office where thousands of real people share one IP address, aren't wrongfully penalized. The primary directive here is simple: do no harm to real users.
Which leaves us with one final and honestly pretty provocative question. Because this cat-and-mouse game, it never stops. As generative AI makes faking text, faking images, and very soon perfectly faking basic human behavior cheaper than ever, how are these behavioral defense systems going to adapt next? The architecture we've explored today is incredibly powerful, no doubt, but the line between human and bot is getting blurrier by the minute. Thank you so much for joining me on this explainer, and remember, keep questioning how the systems around you really work.